Okay, so let's talk about what an ellipse is. An ellipse is of the format x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And if you look at this, this is very similar to the circle, which is the formula x minus h squared plus y minus k squared equals r squared. And in fact, the circle formula is the same thing as the ellipse formula. It's just written in a different way. So note, if you divide by r squared, you get x minus h squared over r squared plus y minus k squared over r squared equals 1. Now the difference between these two formulas is this top formula has a squared and b squared, whereas this formula has r squared for both. And that's because the radius on a circle is the same whether we're going horizontally or vertically. But on an ellipse, a and b are different. And that's the big change. Okay? So, with that being said, we can now approach this sort of problem where the center is still going to be HK. The vertices correspond to whichever side is bigger. So, in number 1, which is what I'm going to do in a sec here, clearly the y value, the number under the y value, 169, is bigger than 49, the value under the x squared. And so this ellipse is going to be stretched more vertically than it is horizontally. So whichever denominator is bigger is the way that it gets stretched. And so if the bottom of the y is stretched, then we have a vertical ellipse as opposed to a horizontal. Okay? So the vertices correspond to the bigger, whereas the co-vertices respond to the smaller. Okay? Then there's this thing called the foci, and the foci has some special properties. I'm not going to get into too much depth here, but the equation to calculate the foci is a squared minus b squared equals to c squared. An easy way to remember this is that if you look over here, the ellipse has a positive, this is a minus. And also it's important to note that this is very similar to the Pythagorean theorem. There's a reason behind that. I'm not going to get into that right now. But just remember, it's always the opposite. So if this is a plus, this one's going to be a minus. Okay? Length of the major axis, this is always going to be 2 times the bigger value, whether in this case 169 is bigger than 49, and the length of the minor is going to be 2 times the smaller. Okay? So 2 times the bigger is going to give me the major, and 2 times the smaller is going to give me the minor. Sorry, I'm running out of space here. Okay? So, now that we have this kind of game, I encourage you to pause, look back, make some notes to yourself, but once you get this down, let's now approach the problem again. Okay, so what am I going to do here? Well, I'm going to start with the equation, x squared plus y squared, x squared over 49 plus y squared over 169 equals 1. From this, because we know it's of the format x minus 0 squared over 49 plus, what's a 49, plus y minus 0 squared over 169 equals 1. We know that the bigger value is 169 and the smaller value is 49. Okay. Also note here, we say a squared and b squared. That denotes that we must take the square root. So the square root of 49 is 7, and the square root of 169 is 13. Okay. So what does this mean? Okay, this means my center is going to be at 0, 0. Okay. Now, I think it's important here, even if it's not asking you to draw a picture, it's important. I think it's useful to draw a sketch. So I'm going to put my center at 0, 0. And what do these numbers mean? Well, the 13, because it's under y, means I'm going to go up 13. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's kind of high there. It's okay. I'm going to go 13. So there's 13. I'm going to go 13 down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 at the bottom there. Okay. Let's choose a different color here. Orange. Okay. So the other value, 49, which is now 7, square root of 49 is 7, tells you how much you go left and right. So we go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, your picture's probably going to look better than mine, but if I try to draw this, this thing's going to look something like a football. I suppose a football. Okay, it looks something like that. Okay? This value in brown right here, these are my vertices. So you know your vertices are going to be at 13, 0, 13, and 0, negative 13. And you know the values of your co-vertices are going to be, what did I say this was? 7, negative 7, 0, and 7, 0. So my vertices are here and here, and my co-vertices are here and here. Okay? And those values correspond to whatever you have under y and under x. Now keep in mind that if these values, if I had 169 under x, this would be a horizontal ellipse, and I'd be stretching it out horizontally as opposed to vertically. So the bigger value is not always going to be under y, it's just under y in this particular problem. Okay? So we got it. Our vertices are going to be 0, 13, and 0, negative 13. And my co-vertices are going to be negative 7, 0, and 7, 0. Okay? Alright, we're getting there. Now let's figure out the foci. So the foci, we said, is going to be done using a squared minus b squared to equal to c squared. And what c represents, c is the distance the foci is from the center. Okay, now I have to make a little note here, and this will depend on what set of notes you look at, but, and I honestly can't remember how Mom assigned it. I think she did this. So if we look back on the previous page, A and B, some people will always say whatever's under X is A and whatever's under Y is B. And other people will say A and B corresponds to whichever is bigger. So they'll say something like A is greater than B. Okay? So over here, if we assume that A is greater than B in this formula, which I have to assume in order for it to work effectively, the bigger one's going to go here. And the reason why we do that, of course, is because we want the difference to be positive and not negative. Okay? So the bigger one is A squared. Now keep in mind, this whole value represents A squared, and this whole value represents B squared. Okay? So we're going to do 169 minus 49. And if we solve this, we end up getting 120. And so what I can say now is that 120 is equal to c squared. If I square root this, 120 breaks down to square root 4 times square root 30, which becomes 2 square root 3. Okay, so what does this tell me? The 2 square root 3 means that from the center, it's 2 square root 3. Now, there's a question here, which is, I said from the center it's 2 square root 3, so does that mean that I go left, right, or up and down? And the foci always follows the larger value. So 2 square root 30 is going to follow vertically. So we'll go up 2 square root 30 and down 2 square root 30. We have yet another question. What the heck is 2 square root 30 equal to, especially if I don't have a calculator? Well, we know this. We know we know 11 squared is 121, so the square root of 121 is going to be roughly 11. I mean, it is equal to 11, so this guy is going to be almost 11. So, almost 11. Okay? So now that I know that, I can kind of pinpoint exactly where this is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a little bit. So there, we'll put F, and we'll do the same thing here. And so we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a little bit, and there's F. Okay, so what is that value? Well, it's sufficient to say that since this is going vertically, we go 0 plus or minus 2 square root 30. So if it's not pretty, it's kind of like with the quadratic formula. I don't need to clean that up. 2 square root 30 is sufficient. Okay? Now, all I have to do left is the major and the minor axis. So, what's the major? Remember, I said it's 2 times the bigger, so if I'm assuming that the bigger is always A, it's 2A. What is A? A is the square root of 169. So 2 times the square root of 169, which is 13. So the major is 26. The minor is 2 times the smaller one, which is 2B. So 2 times the smaller one, which was 49. I'm sorry, which is 7. Square root of 49, which is 7. And that gives me 14. Bada bing, bada boom. And there's our answer. Okay? So that's a lot. I advise you to go back through, watch the video a couple of times, but I think once you get the hang of it, you'll realize that this is not that bad at all. Alright guys, see you on the next video.